And we're live. Awesome. Hi, everybody.
Hi, Mr. Wojcik.
Thank you. No, that was great. I really felt the connection there. Welcome back to Python, where we don't learn anything about snakes, but obviously we're going to learn about turtles, because that makes sense, right? Tracy the turtle. Now, so the way this class is going to work is I'm going to go over a few things on the CodeHS site, a couple lessons, some new techniques, terminology, things like that. And I'm going to want you to kind of document this in your notebooks to kind of keep a running log of everything. Because a lot of times with coding, it seems to like make sense right away, but then you might forget a few little nuances and stuff like that. So we are going to start by creating this little Python notebook just to give us a guide to use as like reference. The big thing with computer programming is that typically no one knows everything about any single coding language. And so any programmer knows where to go to look things up. You know, oh wait, how could I do this? And it's all about sharing techniques and coding and helping each other out. That really makes this programming community really grow. So to start things off, let's talk a little bit about my Power School Learning page. There's not going to be a lot of info on here because we're pretty much going to be living in CodeHS. That's the main website where we're going to go to get everything we need and learn everything we need. The one thing that you might really want to use on this site, however, is the calendar. Because the calendar is where I'm going to post what you should be working on and what you're going to do. So right here, if you click on calendar, whenever you're online on my P-Learning page, you'll see that it's going to tell you what we're doing that day. And of course, they're grouped into two groups because we're block schedule, right? So I'm going to be teaching the same lesson to each half of the class on these alternating days. And so we are moving Tracy the turtle today. And if you click on any one lesson, it's going to show you, well, let me show you it as a student. Moving Tracy the turtle. So then you should see that I'm going to list the lessons right here that we're going to be working on. So if you ever miss a day or you're at home and maybe you missed the start of my lesson or whatever, and you're like, hey, what do we go over that day? Jump back in the calendar and I'll tell you exactly what you should be working on to make sure you stay on pace. Because a lot of this class, you're going to be able to move at your own pace. Everyone's going to be working a little bit differently, but there are certain like benchmarks that you should be at this point by this day and this point by that day to make sure you don't fall behind. As I said before, you're probably not going to have any homework in this class. Yay, which is awesome. But some challenges might take you more time. And so maybe you do need to put a little time into a challenge or two outside of class. And then the calendar here is just going to be there for you to see, okay, what else do I need to do to catch up, to get to where I need to go? Oh, what's that, Jordan?
We don't have the presentation up. Apparently, I'm the only one who has it.
No one else has the presentation up?
Yeah.
Okie dokie.
Well, it didn't pop up for them.
Thank you. Let's see what's going on. All right, present to class. Present screen. Everybody. Is that any better? Technical difficulties on day one. Who would have thought? A new one popped up. Maybe that's it.
He thinks it might be that only people on Chromebooks can see it.
Oh, yes, you have to be signed into your Chromebook through your school account to see this. So, is everyone, can you get on to your Chromebook? Can't see anything, Keegan? Says student is offline. All right, let me try something different then. Stop the screen share. Let me mute that. Present this screen. And back here. All right, all of you at home, can you see this and can you hear me? Got it, got it. We're good? Can everyone hear me besides Matthew? They're typing to me in Google Meet. Yes.
And they just talk.
Well, they're all muted right now.
But there's an unmute button.
Okay. All right, well, I'm going to keep on talking and teaching. And hopefully we're good. Okay, everyone at home, let me know if there's still some issues. And then I can work on this later. Again, I won't be talking the whole time. So here we go. So this is the main starting screen in Python on CodeHS. You don't need to be on the Chromebooks just yet. I'm going to be going through the lessons up here. Like I said, every lesson does have a video for it that you can watch, but I'm just going to kind of go through the video or the slides myself to give my own take on it and to kind of move it along a bit quicker, because you don't need to necessarily watch the entire videos, but they are there for you if you need it. You can't hear. So you guys still can't hear me. Man. Can anyone at home hear me? No? I can. Ian can. Microphone. So you're muted in the Google Meet. Am not. Some people don't have the Go Guardian going. Other people can hear me?
Your audio is coming out of the presentation, so the people who that's not working for can't hear you.
Oh, I see. That makes sense.
If you unmute in the Google Meet, they should be able to hear you.
Okay, let's try this. Can anyone hear me now? Let me stop this. All right. Can you hear me now? Yes. Great.
You only have 8 people in your other class?
I have what?
8 people in your other class?
In the other half?
Yeah, in
1, 2, 3,
cohort
4, 5,
B.
6, 7, 8, 9, 10, 11.
You're only 8 on you.
All right, there we go. Okay, let's get back to Python. And I'm sure that's the only technology issue we're going to have the entire year, right? Because that's pretty much how it goes with this. No technology issues whatsoever. Okay, so Python. Let's talk about it a little bit for my screen. So this, again, I'm just going to kind of go through it up here. You don't need to follow along on your Chromebook for now. I just kind of want you to watch and see what I'm doing. And this first one is just kind of giving you an intro. I want to give you a little bit more background about Python and computer programming in general, because a lot of you, this is your first course, your first time seeing any computer programming. So here we go. Welcome to Intro to CS in Python. You are about to embark on an awesome journey of mental gymnastics. That sounds amazing. And problem solving. So we're going to learn basics of programming, and we're going to learn about Python. I mentioned last week that Python is just one single language for programming, and you can learn in any dozens and dozens of programming languages that can all do the same thing, but some are better for some type of programs, others are better for others. And Python is used in things like Google and YouTube and CodeHS. So I'm sure you're familiar with some of those websites, perhaps. And we're going to be making some games, writing programs, and just give you a great foundation of coding, see if that's something you want to pursue more in the future. So welcome. Hey, that was the first lesson. You all made it through. Good job. Just a little overview of what to expect. Again, before we get into our actual lesson. As I mentioned last week, we're going to start by learning how to code in Python with Tracy the turtle. And that's Tracy right there. Everyone say hi, Tracy. Hi. Thank you. Thank you, Joey, the one person to say hi. Tracy the turtle. Adorable. And Tracy's a turtle that we're going to be commanding for the first unit. And this is just to get our brains thinking about how programming works, because programming is telling a computer what to do, and you have to be very deliberate, very direct. And so a great way to get yourself in that mindset is by telling a turtle what to do, because obviously you have to be really direct when you're commanding a turtle, you know, because they don't really listen much, and so you have to be very specific.
Yeah, Carol's better.
You don't know. Don't you bring Carol into this. And look, you can make smiley faces with Tracy. Won't that be fun? Yes. Yes, it will be amazing. You're going to write programs. Once we get past Tracy, this is more what your Python program is going to look like. You can write the code like this, and you'll have things on the screen. You can type stuff in. It can do calculations. It can make other stuff output. And you can make little guessing games we'll make. And a whole like hangman game where it's taking different input from the user, making decisions and changing what it outputs. We're going to learn about something called object-oriented programming. Don't worry about that for now. That's like second semester. And then we're going to analyze texts. And it can read an entire work of William Shakespeare, for example, and edit it or count it or determine who wrote this piece of literature, things like that, which is pretty cool. So that is all of the basics of the intro for the year. Now, let's get to the actual coding. Here we go. So we're starting off with Tracy the turtle. And this is where the real coding is going to begin. So who is Tracy? Tracy is this adorable little turtle. She's got a head pointing off to the right. And Tracy will follow any commands that we give her in Python, our programming language. One such command is this forward command. Now, a command is something that we're going to tell her to do. They have to type a certain way to make things happen. So this is the first new term that we're learning, and this is what we're going to make in our notebook. So before you start writing anything down, here's what I want all of you to create in your notebook. So I've made a little template right here as to how I think you should kind of set up your notebook. And so you're going to have, we're going to be learning all kinds of new terms, because this is new for pretty much all of you. We've never really programmed before. Some of us have. But you've got unique words to Python. And so I want you to kind of make a table, if you will, or however you want to organize it. This is how I'm going to. But basically, we're going to be learning all these new commands, new specific words or terms that we can type into the programming console, into the computer, that's going to have an effect. And we want to keep our notes here to organize all these things. So maybe when you are working on a program a couple weeks from now and you might forget, wait, how do I make Tracy do this or do that? You're going to have a little reference on how to do it. Now, the only reason it's all blacked out is because I've pre-filled it out, and I'm going to be revealing that to you as we go on today.
Where's that last one?
Example. Yep.
No, I just want to-
It's all right. We'll help you.
And then the glasses, they're gonna be even more thick.
Oh, man. Are they going to be like binoculars with like zoom in function?
Apparently, I'm able to get contacts.
Okay.
How they're gonna come out to you.
Can't blink. So we're just going to have these different words, and I want to give you an example and show you how to use it. So this is going to be like your main reference that you're going to keep on using while you're typing up programs. A little guide to help you out. And this is going to go on. We're going to keep on adding to this throughout the entire semester. And so you don't need to worry about, how big should you make your table. You can organize this different ways. It's obviously going to be multiple pages by the end of the year. And so just for now, just to keep things organized, this is at least for Unit 1 for Tracy the Turtle. So let's take a look at some of these. So the first thing that we've learned about is Tracy. Tracy's great, isn't she? Yes, Tracy is awesome. All right. So classification, what I mean in this category is like, what is it? And so she is technically considered an object. And again, we'll learn about like what objects are later on. But as far as this goes, she's an object. She's something that shows up on the screen that we can manipulate. That would be an object. And like a video game, an object might be like Super Mario, right? He's an object. He's moving on the screen. You can control him and manipulate him. So Tracy is an object, and that's like what she is. And the actual definition would be that she is a turtle that follows Python commands. Okay, Tracy is this object. Okay, that's the type of thing that she is. She's an object. And the definition of Tracy is she's just a turtle that follows Python commands. We're going to be commanding her for this whole first unit. Now, syntax and example, we don't have any of these things for Tracy because she's an object. What we will do, though, is, well, let's learn syntax. That's a new word for probably most of you. Syntax. It's not a word we typically speak in English. So what does syntax mean? So some things in this little note guide, they're going to be just new terms. This is just vocabulary. All right, so this is a new vocabulary word.
Syntax is what grammar.
Yeah. It's kind of like grammar.
But for the language. For friends.
And that's exactly right. So syntax is a vocabulary word. So it's just a new word you need to learn. We're never going to type the word syntax, but we do need to know what it is. So it's considered vocabulary. It's a term you need to know. And when we refer to syntax, it's kind of like the grammar of a programming language. So like in English, we have to have a certain word order, like an object, a verb. You got to have like a period at the end. Like if you don't have those things, you're not really using English properly. You know how whenever you're saying something, when you're speaking a sentence, you have to have words in a certain order for it to make sense, or else it doesn't work. The person you're speaking to doesn't know what you're saying. Like if I stop talking, like right here, this definition that I wrote, those words need to be in that order for you to understand. If instead I said language, correct, way, grammar, programming, a, of, your, to, the, that's not going to make any sense to you, right? Because there's a specific order that we have to have those words for that sentence to make sense. Syntax is how all the words in a computer programming language have to be in order. And if you need, certain punctuation at the end, how it needs to be typed out in order for the computer to understand what it is you're telling it to do. If you don't have it typed the right way, then the computer can't understand you. And so that next column that I have syntax, how to type it, That's basically going to be, well, this is how you're supposed to write something. So with Tracy, we have our very first command, which is forward. So this is what we're going to be filling this notebook up primarily with, commands. Forward is our very first command word, meaning we can type the word forward into our computer program code editor place, and it's going to tell Tracy the turtle she's got to move forward. This is a command. We're going to be learning a lot of commands this year. And so that's your very first one. So the classification, that is a command. And the definition, what does the forward command do? Well, that one's kind of self-explanatory, right? It's going to move Tracy forward a specific distance. Cameron, do you have a question? Okay. So the forward command moves Tracy forward a specific distance. So we want her to move forward. We say, hey, Tracy, move forward this far, or move forward a little bit, or a lot of bit. Now, we actually do have syntax for this. The way you tell Tracy to move forward is you type the word forward, and then you've got parentheses, and now inside, I've got this kind of in italics. Let me, oops, make that like a different color. So you're not going to ever write the word distance in there. You're typically going to write a number, and that number will tell Tracy how far she should move. So for example, this is what that could look like. Forward 30. So this right here, this is exactly how you would type in a command that would tell Tracy the turtle to move forward 30 pixels, a distance of 30 on the screen. Yes, Noah?
Does there need to be anything after it, like
No, no semicolons. It is, it's different than JavaScript or Java. So that's our first command. Let's take a look at how this works. So here you see in the example, they've got Tracy moving forward 100. And Tracy the turtle then moves forward and leaves a line behind her. So let's take a look at that. This is the code editor right here. And the way this works, here, let me change this for you. So the way this works is the big part of the screen is where you're going to be able to type our commands that Tracy will follow. There's a green run button over there on the right. Whenever you hit that run button, well, the program will run. It'll do whatever you tell Tracy to do. So here on the left, if I type in forward and then hit run, well, Tracy shows up, but she doesn't move forward. Why not? Yeah. That's right. I need the distance. Okay. Tracy knows I'm trying to move her forward, but she doesn't know how much. So then can I just write forward 50? Does that work? What else do I need? Yeah, we need to put those parentheses there. All right, so forward 50. Now when I hit run, look at that. Tracy moved forward. It was pretty quick. I can run it again and she keeps on moving forward. Every time I hit run, it resets Tracy back to the middle of the screen. Now I can change this number if I want. I can make it 500. Oh my gosh, what's gonna happen? And she goes off the screen and we've lost her. And that's the end of the semester then, because we don't have Tracy anymore. We lost her. No, we can bring her back, I think. Yep, there she is. Noah?
What would happen? Is there a way, like, if there were two objects, so you would have to define an object?
For now, we're only going to work with Tracy. She's the only object you're going to be controlling in this class. So you don't need to worry about other shapes or objects or sprites or things like that. Now, I could type forward multiple times, forward 50, and then forward 100. And, well, how far did Tracy move altogether? Yeah, 150, right? So you can tell Tracy to keep on moving forward, and that's going to keep on happening. Now, we've got a new command, circle. Awesome. So this command, circle, it's just like forward, but instead of moving forward and drawing a line, this command tells Tracy to draw a circle. You can see the way that it's written, circle, parentheses, radius. But do you think I'd actually type in the word radius? No. You wouldn't type it in. You're going to type in an actual number. And can anyone tell me what a radius is? Janina? Half the diameter. Right. So right there on the screen, the radius, if you look at this circle, it's the distance from the center of the circle to one edge, to any edge of the circle. It's essentially the size of the circle. The bigger the radius, the larger the circle will be. And so when we type the command circle with some number in the parentheses, that tells Tracy to draw a circle of that size. So let's go to our notes if we haven't already. And we've got a few new terms. We've got, a new vocabulary. Oh no, what did I just do? A new vocabulary term, the code editor. It's just another vocabulary word. And that's the place where you type code. And then the next thing we have, oh, we don't have that one yet. Circle. A circle is a new what?
Command.
That's right. Let me delete this row. Okay, so the word circle is a command, right? It's a new command that we can tell Tracy to do. And the definition of it, well, what does it make Tracy do? Yeah, it moves Tracy in a circle. Okay, the syntax of this command. What do we type? And then distance, instead of distance, I'm going to write, radius, because she's not technically moving that distance around the circle. The number we put in there is the radius, like how big of a circle it should be that she's actually traveling. We'll make that green. An example of this would be circle, parentheses, I don't know, 40. So just plug in a number. So that's our next command. And let's take a look at this. So I've got that forward command. And after it, I can write circle 40. I'm going to hit the stop button. And then to run it, what do you think is going to happen? Is Tracy going to move forward or just do the circle?
Go forward and then circle.
All right, so I've got two different lines of code here. And so whenever you run a program, it's always going to run, the lines always run in order from the top to the bottom, the same way we read, one line at a time. So Tracy's going to first move forward 50. And it's going to wait until she's done that entire move. Once Tracy's moved forward 50, then she's going to draw a circle. So take a look. So Tracy moved forward 50 and then drew a circle of radius 40. Pretty cool? Yeah, didn't that look fun? It's like a little loop-de-loop. Now, if I want, I can still write commands after that. I can have her go forward 30 afterwards. And she'll go forward, do a circle, and then keep on moving. Or 70, make it more. Look at that, nice little loop-de-loop. And so that's your basics of commanding Tracy. Noah?
Do you have to say we're fast? Tracy, would you have to draw an object that would move first?
We're not going to be doing objects in Python other than Tracy. so no need to worry. So different commands, you can write as many as you want. Now what if I write circle 10, circle 10, circle 10? What do you think is going to happen?
It's just gonna go over the circle 3 times.
So we go 1, 2, 3. She's getting dizzy down there. Since I didn't have her move in between each circle, she just made that same circle on top of herself every single time. And so she's going really fast there, though. She's got to be dizzy. So, I wouldn't need to write that. So just a single circle command is fine.
So it starts in the, or so she starts in the bottom of the circle.
That's a good point. Yeah. So if you look at this, Tracy starts on the bottom of the circle. That's an important note to make, I think, so that she's always drawing it so that the circle is kind of like above her in a way. Now, here's an example, and you're going to help me write this. We want to write a program that has Tracy draw a slinky with 5 loops. So there's 5 circles there. So I'm going to have to type the circle command 5 times. So let's see. Let's delete this. So circle, let's make it 50. You know what? I need 5 of these, right? So let's just copy and paste and run it. And there's our slinky. And not quite.
You have to move.
So here's what we want to try to create. What do I need to do? Quinn? There we go. So after Tracy draws 1 circle, let's have her move forward. Forward. How far? Oh, yeah, let's try 20. All right, let's see what happens here. 1, forward, forward. So after each circle, it's really hard to see because she's moving very quickly. But after drawing 1 circle, she moves forward 20 pixels before drawing the next circle and continues that. Draws a circle, moves forward, draws another one. So we can see each of them, and we've got our slinky. Pretty cool? Anyone have any questions at all yet about Tracy? I know you want to play with this, don't you? She's fun. Yes, Noah?
Is there a way that you can make Tracy turn?
Yes, absolutely. So this is the first lesson. Now today I'm going to go through 3 different Tracy lessons, and then you just have the rest of the time to code. Here's what you should be doing after I release you to coding time. So looking down here, this was the video camera, the video lesson. You don't have to rewatch the video. I just went through it. You can if you want to, but you don't have to. Then there's going to be a little multiple choice quiz right here. And I'd like you to answer these. Try your best, but don't worry if you get one wrong. I don't grade these. It doesn't go in the grade book. This is just your own little check to make sure, okay, am I understanding what was taught in this lesson? After that, there's usually an example of what we went over in the video. So here's that circle forward to make that slinky like we just saw me do. And then the last thing, this little pencil icon, that's the exercises. That's what you're all going to be doing yourself. And so for this one, this first exercise, when you load it up, it says write a program that will have Tracy draw a stretched out slinky. Same idea, but it's going to be stretched. Don't you hate that when your slinky gets stretched out and it doesn't slink anymore? It's the worst. Then it becomes a wire. It's not fun at all. And now there's some specifications. It wants 5 rings or 5 circles. And it's telling you right here what the radius is and then how far forward you should move between every one of them. So I think you all pretty much get the idea of what to do for this one exercise. You're just going to type it here in the code editor and hit run. Now, a few other things about the code editor that I do want to go over for you. First off, there's this check code button. So CodeHS does have an auto grader built into it that'll automatically check to see if you did the program correctly. And so if I check it right now, you'll see that it's red, meaning I've got it wrong because my program's blank, right? I didn't type anything, so obviously it's wrong. And so what it wants me to do is try to figure it out how to type it. Now, here's the thing. I'm going to tell you up front. The code editor is not perfect. It doesn't actually analyze your code and make sure it does complete the challenge. It can't. It's not a perfect artificial intelligence computer to see if what you did accomplished what it wanted you to. And part of that is because programming is so different. You all can create your own program. It allows a lot of room for creativity. So you could all have slightly different programs that all accomplish the same thing. So instead, you see there's little criteria here. It says that you should have 5 forward commands and you should have 5 circles, each with a radii of 35, right? Kind of like that example I did where I drew a circle, move forward, circle, move forward. But if you're just trying to pass the challenge, all I need to do is have 5 forward commands and 5 circles. So technically, I could write forward 40 like this and just copy and paste it 5 times. And then same thing with circle, circle 35, right? Copy and paste. Now, is this going to draw the stretched out slinky that I want? No. Absolutely nothing. Oh, we have an error. Dun, dun, dun. Okay, if I run it, oh, I misspelled forward. Hey, here's a really neat thing that you can do with CodeHS. This is a great learning opportunity. Instead of clicking everywhere to type, see how I forgot the letter R in forward? In CodeHS, if you hold the control button on your keyboard, hold control and click the cursor. Oh, not there. Look at this. I can have multiple cursors going at the same time. And if I type it one place, it types it everywhere. What? That's crazy. I know. So there Tracy goes, and there she's drawing her 5 circles. Clearly, that's not a stretched out slinky. But if I hit check code, check it out. All green. So do you see what I mean? Why just getting all green shouldn't be your goal. Your goal should be to complete the challenge correctly. All right. So that does not count. Right, Joey? Just checking. Assignment up here. This is always a nice place. Instead of clicking show exercise where this pop-up window shows up, you can click assignment and see what you're supposed to do over here to remind you. And this is what your screen should look like. Even though my screen didn't look like that, I still passed the exercise. Again, the auto grader is limited in what it can do. Another really useful thing is docs. This is the documentation. This is kind of like a go-to place. If you're like, how do I go forward? It's all right here. And all the future stuff we're going to learn is here too, but we'll get to that. All right, so I know that lesson took 40 minutes to teach you how to move Tracy forward and to draw a circle. We're going to be moving much, much quicker. So these next two, I do want to go through and then just give you the rest of the time to code because we've got like an hour left, but you're going to finish these challenges in like 2 minutes probably. So let me just go through 2 more and then that's going to be it for today, okay? And most of the time, I won't be talking anywhere nearly this long. It's just because I have to show you the basics and how everything works and stuff like that for this first time, okay? So lesson 2, and these will go a bit quicker. Tracy's grid world. Tracy lives in a grid world. Have any of you seen something like this before? In a certain math class, perhaps? Right? A coordinate plane, x-axis, y-axis. So when we're talking to Tracy and telling her like where she can move and how far she can move and stuff like that, it's just like points on a coordinate plane, just like in a math class. There are 2 values, an x coordinate and a y coordinate. The x coordinate is how far, left or right you are. The y coordinate is how far up or down you are. Tracy starts out in the middle of the screen, which is 0, 0. The origin, just like in a math class, right? We always start at 0, 0, right in the middle of the x and the y axis. You can see here that the edge of the screen to the y-axis, same thing. It goes from negative 200 at the bottom to positive 200 at the top.
That's scary.
in the corners, you can see they go from negative 200, positive 200. Because from the middle, if I went left 200 pixels and then up 200 pixels, this would be the coordinate up there. Again, just like in a math class. Now, one thing I do want to address, these numbers, this 200 or 00 or 50, or when I tell Tracy to move forward 40, I'm not giving an actual unit. Now, in any good math class, you know that you need units, inches, meters, miles, kilometers. So does anyone have a guess as to what these units are? This 200, it's 200 watts. Evan, what do you think? Pixels, yes. Have you ever looked really close at a screen and seen teeny tiny squares that actually make up your image you're looking at? Each little square is one little pixel. Each pixel can only be one color. And when you get really close, you see that when you put a bunch of these little colors together, it makes blended pictures or like a curve. That 0 is not really round. If you get really close, you see a bunch of jagged edges because it's actually made up of a bunch of little squares called pixels. So when we say move forward 50, Tracy's moving forward 50 pixels on your screen, just so you know what that's referring to. All right. I'd recommend in your note maybe making just a quick grid of this with those numbers, negative 200 to positive 200, if you don't have it yet in your notebook. So I'm not going to go back to my my spreadsheet template for you every class. That's something that you're going to be working on yourself. That's just my recommendation, but I definitely suggest writing this grid world, noting the center and noting how far you have to move in each direction. But because if you tell Tracy to move 300 pixels, she's going to be off the screen. And you might be like, where'd Tracy go? I don't see her anymore. And so you can look back at your notebook. Oh, yeah, what's going on? Obviously, Tracy is off the screen.
You know how less complicated Java would have been if JavaScript would have been if 00 was in the middle?
Totally different programming
In my
language.
brain.
You can't compare the two. Don't use your JavaScript knowledge in Python.
Yeah, no,
It's different.
it's very.
All right, so just a quick note of the grid world should be useful to you. So notice that the entire width of the screen of Tracy's world, where she walks around, is 400 pixels, right? Because you have 200 to the left and 200 to the right, total of 400. Same thing vertically, 400 pixels, that's the maximum height of that screen. So again, if you have Tracy moving 500 pixels, she's going to be off the screen.
Is that the same thing as like resolution? So like if you're watching a video, it's like 480p instead of
Mhm.
480 pixels.
Yep, I'm sure you've all heard of like the resolution of a TV, for example, or a screen. And that resolution is actually the number of pixels. The more pixels there are on a screen, the sharper their image is because they're smaller and smaller squares. So it's hard to see that, and it makes a more smooth, curved edge on something. All right, check it out, everyone. We have a new command. Let's put that in our charts. The backward command moves Tracy backward a specified distance. So you can see the forward command moving Tracy forward 100, that leaves a line behind her. When we're moving backwards 100, well, notice that Tracy isn't changing where her face is, where her head is. She's keeping her head still pointed to the right. She's just moving backwards a set distance, still drawing that line. So that's your new backward command. And the way you type it is there in that yellow arrow. That's the correct syntax. So you just type the word backward, just like the word forward. Notice that they're all in lowercase. That's another new thing that most of you are probably not used to. Usually when you write the first word of a line or of a sentence, you always capitalize it. In Python, if you capitalize that first letter, it's going to error because Python doesn't recognize that capitalized letter. It only knows this forward command all in lowercase letters. And then the parentheses, that distance that you want Tracy to move. And again, that is in pixels. That'll move her forward or backwards 100 pixels. Oh, two more terms. Pen up and pen down. So we've all seen how Tracy, when we move her, she leaves a trail behind her. I want you to think of that as if Tracy's holding a pen or a pencil, or maybe there's like a pencil tied to her tail, right? And whenever she moves or draws a circle, she's leaving a trail behind her. Well, imagine that means that there's a pen that Tracy's holding, and the pen is down on the paper or on the computer screen that she's writing on. So the pen always starts out in the down position. But what if you want Tracy to move somewhere else on the screen and you don't want her to leave a trail behind? Well, then you can type the command pen up. Now, very important to notice that the pen up command does have parentheses, but it's weird because there's nothing inside of them. Those parentheses are empty, and you actually need that. You need to have those parentheses there. That's what tells Python this is a command that we're giving Tracy. Even though there's nothing in the parentheses, you still need them. Basically, you don't need to tell her like how far up she needs to lift her pen. If the pen's up, it's up. You don't need to give her any more information about that. Where if we told her to move forward, she has to know, well, how far forward should I go? So that does have a number in the parentheses, where the pen up and the pen down commands do not. These are two new commands: pen up, pen down. Pen up, think of it as the pen is coming up off the paper. Pen down, think of it as you're putting the pen down on the paper so that it actually will draw a line and leave a line behind Tracy as she's drawing it. Any questions on these new commands so far? Who's excited to start coding? I know you're itching at it, right? I know. Just hang in there. Super close. I just want to get through a bunch of these so you're not just like doing two things and then stopping for the rest.
I feel like this is going to be harder than reading my JavaScript now that I have this JavaScript knowledge.
It's different languages.
Yeah, my brain hurts.
All right, so I'm not going to force you to sit here and watch me draw this, but if I were to make Tracy draw dashed lines, I would start by having her move backwards to the left edge. I'd put the pen down. So those are your three new commands. One last thing, and then it's go time. Turning, right? We want Tracy to obviously do more than just move forwards and backwards. There's a whole big canvas to go into. So let's learn how to turn Tracy, and then the rest of the class will be yours. So she always starts facing to the right. That's along the positive x-axis over here. All right, so what about moving beyond the x-axis? We can go forwards, we can go backwards. But what if I want to move up here or down there on the bottom of the screen? How do I get there? Two new commands, everybody, and they're pretty straightforward and simple. The commands are just called left and right, and that tells you which way you want Tracy to turn. So jot these down in your Tracy notebook. And these also have a number. Now with forward and backwards, the number or the radius of the circle was in pixels. Here, what are the units of the number for turning? 90, is that 90 pixels? Degrees, right? So whenever we measure the amount of rotation or the amount that something turns, we typically measure it in degrees. So 90 degrees, that's what we call a right angle. So that's a perfect corner, right? That's like how the floor meets the wall at a 90-degree angle. So it's a perfect sharp turn. And you can see those two illustrations down there. The one on the left, Tracy's turning left 90 degrees. So Tracy would then be facing upwards towards the top of the screen on the positive y-axis. Or if Tracy turns right 90, then she would be facing down on the negative y-axis. And of course, from there, you can still have her move forward. You can still have her draw circles. You can still have her bring the pen up or put the pen down. And these are the new commands that we've got for Tracy. Turning right and turning left. Do you think you can do numbers other than 90?
No.
For sure. How many degrees is it in an entire circle all the way around? 360, sure. So if you do 360, it'll be as if Tracy didn't move. She'll still be facing the same direction. If you did 400 degrees, she'd go a full circle and an extra 40 degrees past it. So it's the same thing as just doing 40. You don't need to do unnecessary loops unless you want to see Tracy get really, really dizzy. Then by all means, go like 3,000, but it might take a while to watch.
Did she actually turn on screen?
Yes. And so you can make a square, have her go forward, and then you would just, what command would you use? Yep. Instead of just turn right, remember the command is just right. So you just go like forward, then right, or in this case, forward some distance, left 90, forward, left 90, and left 90. You just do that 4 times. All right, you can draw X and Y axes. Again, these examples are in the lesson if you want to look at them and run these programs. And that's it, your last 2 commands. So everyone grab out your Chromebooks. Let's do some coding, finally. All right, so everyone, it is 1:55. We have until 2:38. That is a lot of time. It's about lesson 3. So that final challenge in lesson 3 is called 4 columns. So I want you to complete everything up to that point. Now, one thing with the videos, if you don't complete a video, it stays like grayed out, or it might be yellow if you start it. And I know a lot of students always like, Wojcik, I want to have the completion part. I want to have 100% complete. So if you've already gone through the slides with me, up here you can click on slides, but by default it's on video. You don't have to actually watch the whole video. If you just take the slider and you can just drag it all the way to the right edge, CodeHS counts that as like watching the video, just for the completionists within you. I know some students that often drives them crazy, but you don't want to rewatch the whole video, so you can just skip through it, then go through the quiz questions. All right. Are there any other questions on what's going on or what the expectations are, what you should be doing right now?
I don't know if I got this one.
Okay, so go through it. I am going to stop the recording, but I will keep my Google Meet open for all of you who are at home right now. Keep on working on these challenges. Make sure you get through them. You should have plenty of time before 2:38 to finish these. Whatever you don't finish, though, will be considered homework due before our next class period on Thursday. Okay, and Thursday we'll move on to the next topic with Tracy. So any other questions, let me know.